In developer sense terminology, 6 years ago, it could do a minor autocomplete because it could complete about a second's worth of work of a software engineer. Today, you can give an LLM a software engineering task and it'll complete about an hour's worth of an engineer's effort. And 6 years from now, you can give an LLM a month's work of a software engineer on one shot. How do you design for systems where a single shot LLM can do a month's worth of somebody's work? And so it really upends the entire principles of system design, because system design is about decomposing the work and then, having these sort of units that can manage that.
Welcome to DevAI, where we talk with builders and thinkers shaping the future of software and AI. Today, we are diving into a question that's been bugging me, and a lot of teams experimenting with agents. How do you actually run autonomous agents in the real world without them going completely off the rails? Demos are impressive, but once agents are wired up to the tools, APIs, and systems, the stakes go way up. I'm joined by someone who spent years building fault-tolerant systems and is now thinking hard about trust, autonomy, and guardrails in the world of AI agents. He was a board observer at my last startup and now
Yeah.
leads the team behind Akka, the platform that's been used to scale real-time apps and distributed systems worldwide. Thank you, Tyler, for joining, and great to have you today. And I'm really excited about this particular topic.
It's good to see you again, Balaji. Thank you for having me here.
All right. I know you are a serial entrepreneur. You just talked about a certain startup that you worked on that I'm working on right now, and that the product that you built. Can you just give me a little bit about your background particularly, and maybe talk about your the new company that you're working on?
Yeah. I've had two careers. I've run four DevEx companies as CEO, and the three previous companies have all been acquired. One of them was CodeNV. It was a cloud IDE that I founded in 2011, and Red Hat acquired it in 2017, I believe, and now is the foundation behind dev spaces at Red Hat. And another company I ran was WSO2. They were just acquired by private equity last year. And I'm currently CEO of Akka, which is a company I invested in 2019. And that speaks to the other half of my career, which was products and investment. And I had about 15 years doing products for Oracle, BEA, Red Hat, and that led me to doing a bunch of investments in developer-related platforms.
Awesome. Well, great to have you. And today's topic is really everybody's mind. How do you run agents? And I was actually in an AI productivity engineering meetup at Dropbox yesterday, and everybody is talking about obviously, the efficiency gained by coding, but now they're looking into the next steps of how do I create different agents within an enterprise for developers. Not only the AI coding assistants already doing coding agents,
Yeah.
but like what about the others? And I think the biggest first question I have is what makes an agent really trustworthy? In your mind, what separates a toy agent from one that's safe to run in a production? Are we close to the bar yet for most use cases?
Well, let's start by defining what is an agentic system. And an agentic system, quite simply, is a system where you want to infuse AI into the application. But there's some risk you have to manage around that. Now, first of all, agents are systems. They are compute, they have state, memory that you have to manage, and they operate over a network. The LLM conversation is over a network. So they are a system. And so you have all that systems risk, availability, failover, performance, all the things that come with system. But they're also based on LLMs, and LLMs at their core are randomizers. And because they're randomizers, they have a failure rate that is non-zero, and it's never going to be zero. So you have to deal with issues of context rot, stochastic modeling, emergence AI, which is basically the erosion of the safety parameters of the LLM. And so you now have this sort of randomness risk that you have to embrace that is paired with your systems risk. And so agentic AI is by definition a system that can never hit perfection because there's this sort of randomness element at its core. And since it can never hit perfection, at best, it's a system that strives for perfection. And so we define agentic as one, it's, your apps that are infused with AI, but it's also a system that inherently continuously builds trust. It's continuously striving for perfection, knowing that it'll never get there. And so how do you make an agent trustworthy? Is that you look at it from an agentic point of view. And what you're doing is you're designing a system that's continuously building trust and striving for trust. And so the next question should be, well, how do you do that? How do you think about systems from a trustworthy point of view?
Yeah, I think how do you ground it too so that you're more closer to perfection or remove the risks? I've talked to other in this particular podcast. One of the person was building Kubernetes SRE role. How do you prevent an agent from running and creating new solutions every time? You have a more of a grounded way to run things.
Yeah.
How do you do that?
So, so it's interesting. So we're selling to large enterprises, and this is a bit unusual for us because we used to sell to developers, and now we're selling to like chief AI officers and chief data officers, and they view their entire world from a lens of risk. And the thing about risk is that by definition, risk is a never zero. It's always a non-zero element. And so the way that you manage risk is by putting a really healthy governance process in place, which allows you to have controls, metrics, and policies that define what sort of acceptable variance you're comfortable with. And so if you can have the business define its risk tolerance in a form of policies on that, then there is a whole series of technical things that you do to accommodate that. So we talk about building continuous trust in six pillars. It's kind of a 6-step approach you need to take. The first is you have to start with governance, and you have to come up with a language for defining what is the policies of this agent that you're willing to live with in terms of both business constraints and also kind of content constraints or technical constraints. Then you need to have confidence in the execution. And so the way that you get confidence in the execution is that you have to have an impenetrable runtime and network. I know that's a very infrastructure sort of thing, but there are so many different attack vectors that can happen. You have to start by saying, hey, this agentic system needs to be zero trust in its nature on that. Then you have to say, okay, it's got to have a mechanism of resilience built in, because if the agent or the LLM is ever disrupted, how does it recover from that disruptive activity? So there has to be a form of resilience. Then you go and say, now it has to have a verifiable identity. So you can't just have an agent running without permissions. There has to be identity and permissions that have to flow through to the agents and anything that it talks to. And then that all ties together into an immutable form of audit. So that you can have chain of thought and explainability on the entire system. It can't just be the agent talking to the LLM. You have to do like a distributed trace so that you can replay every logic decision. And so that's the first 5 points. And then you roll this all up into a continuous adaptation where the agent has to be able to gather information from its environment through sensors and then use that could be a guardrail. It could be like an evaluator that are basically giving it intelligence, and then you use that intelligence to adapt the way the agent's going to behave or its memory or whatever other things. So you lay out the governance, you lay out that sort of execution technology stack, and then you put it into a feedback loop so that it continuously improves. And when you do all those things, what you get is a system that's working to better itself, even though it never gets to perfection.
Since you said you're a lot of customers using it in production, where do agents usually break in the real world deployments? Is there some examples you can talk about where some failure modes happened and how it sort of behaved and how did you from it?
It's kind of in, there's probably this sort of a business degradation, and then there's also a technical degradation. They're kind of separate concerns, if you will. On the business degradation, the agents that sort of fail are those that don't have a system for continuously optimizing and improving the prompts, the semantic data that's feeding into those prompts, and the tuning of the LLMs themselves. So if you look at the system as a milestone release that you've snapshotted and you've thrown it out there, and that you don't have an accommodation for what do you do when it starts to deviate or it starts breaking against the guardrails, then there's a kind of a recipe for failure, and it tends to be a project that is discontinued at some point in time. The bigger issue that we run into is that most people who've been building agents have kind of rushed into the open source space particularly the Python open source space with LangChain or Crew.ai, Pedantic, and those technology stacks have made it really easy to get started, and so that you can perceive the concepts of what agents offer you, but they're just not well suited to scaling beyond a few dozen users. And there's just sort of this graveyard of accounts that have adopted that technology stack because their data scientists were comfortable with that. But then the moment they tried to put it into production, there were security issues, scalability problems, data failover. Pick your poison, in that it wasn't really well suited to kind of 24/7 operations. And this is why we made a big prediction. I think the Java ecosystem is on the rise once more because of AI, because the JVM is actually just a wonderful place to run and execute agents in ways that Python never could be.
So how do you supervise these agents? When do you know it's failing? The execution failures you're looking at, or your agent system failures? How do you supervise these?
Well, that gets to the heart of Akka. So before Akka was an AI platform, it was a library for building distributed systems. And the core building block inside of Akka was this thing called actors. And actors are a form of compute, a lightweight form of compute, but they were designed so that you could do massive concurrency, meaning you could run hundreds of millions of actors on a single core. And actors had a structure that allowed them to communicate with each other and to be supervised by other actors on that. And this was all done in a way where there's no multi-threading and there's no locks. So it was a really easy programming model, but you get this sort of high massive concurrency. I say all this because the nature of the supervisors are there to make sure that if particular actors fail or there's a blockage in communication, there's sort of this hierarchical supervision model that's baked into it, so that the system always knows how to self-heal, no matter how big it gets. And Akka then translated that into clusters so that you could do that across clusters and have self-healing networks at large scale. It turns out that actors are the perfect building block for running agents themselves. So our approach is that when you build agents, these agents execute with actor-based systems, which gives you all the sort of resilience capabilities that come along with that. And then you layer on workflow with durable execution so that it can control and guide on a long-running basis the individual agents, which are kind of short-lived. Even though they're running over minutes, it's still short-lived in the concept of human time.
Yeah,
And
I
so
mean,
all those mechanisms lead to kind of a system that always knows how to self-heal given any problem that it can rise.
I mostly use the coding assistants and coding agents.
Sure.
Obviously, I am treating it as a co-pilot. I still don't want to hit to run everything and do a lot of things that like I'll regret or have to undo. How much autonomy is too much? What use cases you're seeing enterprises adopt agents? Is it a niche use cases, or like a general enterprise agents use case, like an HR agent and expense agent? I mean, what is the prevalence? Yesterday I was in this meeting with fairly large name companies, right? And an agent is still not top of the mind. Not as much as I would have expected it. So how much is in real world people are actually running these autonomous agents, and how do they decide on how much autonomy to give?
Yeah. I mean, well, autonomy is a sliding scale. Limited autonomy is where you have a static workflow, meaning, there's 3 steps, you know what the steps are going to be in advance, and you're just executing step 1, step 2, step 3. And you can use agents with that. An agent can be one of those steps, sort of thing. But on the other side of the spectrum, you have full autonomy, where the decision around how many steps are going to be executed and how it's going to evaluate itself and repeat in some sort of loop, that the agent gets to decide all those things, and it can run for a short period of time or it could run indefinitely, sort of thing. So how much is autonomy is too much autonomy? It comes down to the policies that you want to define. So some organizations define too much autonomy on a cost basis because they're happy to let it to continue to run and try to solve the problem until it reaches an LLM cost threshold that they don't want to overstep. And in other cases, it's a quality threshold, or it's a guardrail, like a policy of you've overstepped the line. You deleted a database that you shouldn't have deleted, so I'm going to terminate these sort of things. So organizations take it on a spectrum. Almost all organizations in the enterprise get started with that sort of static approach to it, and as they get more and more comfortable with it, they then start moving over to the fully autonomous. Our customers use us personalization use cases where the amount of data is in real time, and we're talking like petabytes of data to be analyzed to come up with whatever the personalization or the recommendation might be. So that's a fan out use case. Large scale pipelining. We have a medical provider that needs to process a petabyte of documents every day. And then they have 17 agents in a pipeline that act as medical professionals. They've each been trained to think in a certain type of way, and the interpretation of those documents run through that pipeline in that sense. But we've got customers who are doing kind of transactional analysis of large volumes of transactions that are coming in, and you're doing exception analysis on that, where LLMs are better at it than humans. And to a lesser degree, some RAG applications like chatbots and whatnot. Those have kind of been overplayed a little bit, but where we get pulled in is when you want to have this sort of AI intelligence added into like the application services that you're already shipping, and that's where we get pulled in.
Do you feel like any models are performing better in these kind of use cases? If I'm a customer and I'm like, I want to use your platform, what models do you recommend for what use case?
What we've seen is models are definitely use case specific at this point in time, and what we've also seen too is that it's a tricky balance, because even when you have a weaker performing LLM, you can compensate for its deficiencies by designing a multi-agent system with structure and guardrails. So you can take a problem and break it into smaller components to overcome the limitations of the LM. So there's this sort of weird tension that's coming along, which is how much, you know, of the automation do you give to a one-shot LLM versus breaking down the problem into its piece parts and then putting those piece parts into a structure on there.
How does an enterprise really break that down? Like, do you help them break it down?
That gets into good AI design. I mean, that's just an AI design or like an application design. And so, yeah, we provide consultative offerings to help guide them on that. But also, a lot of our business is resold through AI consulting companies. And so the AI consulting companies definitely have a point of view on for the use case and domain. And we're there to implement whatever use case they come
You're
up.
the platform that runs these agents reliably.
Yeah, yeah. We care more about the fact that there's again, you get back to this idea, there's no real kind of milestone where it's like perfected. So you're going to oscillate between having big one shot efforts versus I want to decompose it to multiple ones. And you might want to change that over
Mhm.
time or even dynamically at runtime sort of thing. So really to us, it's more about how do you define what is good, and do you have all the sort of hooks and controls in place so that you can manage this system and fine tune it on a regular basis. And that's really hard for people because they're accustomed to I write software, we're going to have a release. That release is versioned, it's deterministic, and it's meeting the SLA. And you just can't think that way. You have to think like, getting it into production is just the first step. Now you have to manage it. It's an ecosystem that you have to manage.
Let's talk about what are the best guardrail techniques you have seen? Are there any practical ways to constraints what agents can do without killing flexibility, right? How do you sort of
Yeah.
scope the tool access dynamically?
Well, yeah, there's all sorts of things that happen. So the sort of techniques that happen is one, you have inline evaluations, which are the ability to analyze both inputs and results, and then change the behavior of the system, like or maybe even interrupt it. Right. So you're in line to the agent's transaction on that. Uh, that you use that sort of thing when you need to have a binary outcome. Either like, for example, I want to see if there's any hate speech in the prompt that somebody sent to me, and I'm not even going to send this to the LLM. I'm going to interrupt it if there's any sort of hate speech in that. So that's a binary sort of outcome. The other technique that is a probably way more effective technique is systematic evaluations. And this is not like an evaluation from like an observability vendor that's after the fact. It's actually part of the system. And what you do is you basically look for certain types of events, such as this agent was completed, or this agent is waiting for some sort of human in the loop. And you can use those events to trigger judges. And you basically write LLMs as a judge that run in a sidebar on that. And that gives additional feedback. And it can analyze the whole system while the system is running. And then it can give that feedback either to overseers or directly back into the system. And that's a very effective tool because you can layer on these LLM as judges that are running in parallel to the system itself. And that creates kind of a stronger foundation.
What's your some of the biggest deployments or type of companies that are deploying mini agents? Like, what's the scale today look like?
Our largest agentic AI customer has deployed 22,000 cores of Akka, and it's a globally recognized brand in the media space, probably one of the top 3 or 4 brands. And they built out a system that does real-time advertising and content recommendations for their entire user base. And they have both streaming users and cable network users. They have a whole gamut, they have a bunch of different brands. And it runs through a pipeline of 8 different models, and it has to execute in under 100 milliseconds. Each transaction is a sub 100 millisecond performance requirement. And so that whole pipelining and that inference and then the model integration was all done by Akka. They process roughly 5 billion tokens a second. And to give you a sense of that scale, 5 billion tokens a second is about 1/20th the size of OpenAI. So this single account is, on this recommendation engine is about 1/20th the scale of all of OpenAI.
Wow, well, that's a pretty impressive scale there. Is there any other any other companies use cases that you want to talk about? That would be, that's I think it makes it more real.
I think one of the more wild ones is we just literally a week ago signed another enterprise customer. It's a Fortune 500 customer. I can't name who it is, but they uh, uh, are in financial management, and they have $6 trillion under management. Huge company. And they're not just doing agentic AI, but they are very adamant about having a safe agentic AI system. And so they are deploying dozens of separate regions, and those regions are going to have high availability of agentic systems, meaning that you can lose an entire region and the agent will continue processing from where it left off on another region on that. And so it's got full agentic memory replication between all the regions. So all the agents are running in all the different regions, and you can lose a region and the whole system will fail over to the other, and the end user won't know the difference.
That's great. You definitely are in the leading edge of some of these deployments. That's pretty great. Now let's talk about the agent stack. What's missing? If you have to rebuild a sort of an ideal stack for production agents, what's missing today?
This is where we feel like LangChain and Crew have really kind of missed the mark in that most of the things that people use to build agents today are development frameworks. And the thing about a development framework is that it'll let you build an agent, but it doesn't but it doesn't think in terms of system. And in order for you to deploy that agent, yeah, you wrote it, but you're going to also have to have an endpoint, an API to access it. There's going to be some sort of streaming mechanism because that's how you take information from outside sensors and to feed that in. And you're going to have memory. And right now, most of agent frameworks bolt on memory as like a separate type of database on this. And then you're probably going to want an orchestration framework to build workflows to manage all that. And so is it really the case that you want to cobble together each of those different pieces? And then you have to get the models themselves and integrate those models in.
On the evaluation frameworks?
Evaluation frameworks as well. And so that's really, if you look at what a production system is with like LangChain, you're actually deploying like 5 different things and you're managing 5 different things that you've integrated together. So our basic premise is that no, people want systems. They don't want piece parts. And we believe like, look, we want to ship an SDK to the world that gives you the ability to design the entire system. And it's the whole system in the binary so that when you deploy it and activate it, everything that you need is there. So you get it all done, you test it all together, you build it all together, you deploy it all together.
What's the next big unlock? What would make the agent deployment dramatically easier or safer, I think are
Yeah.
scalable.
Yeah. Yeah. Uh, I think in many ways, all the technology to do scalable agentic AI is there out in the marketplace today. I think actually what's holding the industry back is that enterprises are still struggling to understand how they can trust and manage these systems. And there's not going to be any sort of amazing standards that suddenly come online and you just adopt that. The reality is that all enterprises are going to have to go through this sort of experimentation cycle where they put some of these things out there. Frankly, they're going to fail with it, and then they're going to have the same sort of reckoning that we had, which is like, oh, it's the approach of how do we create a mindset of striving towards perfection, recognizing that we're never going to get to that. The sooner the industry can accept that methodology and incorporate it into the way that they work, the sooner we're going to see bigger adoption of it all.
I know that almost everybody's using MCP for tool calling from agent's perspective, A2A or any other agent to protocol that you see. Is it adopted in the wild? Or
It's certainly adopted in the wild. I wouldn't call it being adopted in the four walls of an enterprise. Both A2A and ACP are very interesting protocols. When it is adopted, and I've seen it adopted at like Dell and a couple of enterprises, and we have one customer that uses it as well, they don't get to use it on its purest sense. The pure idea is that these agents can just talk to each other directly on that. And that's just not there's just no way you can have that be secure. And even if they're doing that, then you lose traceability of what happened when they were interacting with each other. So most who do accommodate this, they do it through a workflow. So there's a workflow that is acting as the 808 proxy, if you will, and it's talking to each of those things on behalf of instead of each other. And when you have a workflow that tracks it all, then you have control and manageability of the system.
got it. And so what is 5 years from now would look like?
I think the question's more interesting on a 6 years from now.
Okay, 6 years. Okay.
And the only reason because is that LLMs really came to fruition 6 years ago. And if you look at those LLMs very consistently have doubled their productivity every 7 months on a logarithmic curve. It's been wild, right? It's just a straight line curve. And what that means, like in developer terminology, 6 years ago, it could do a minor autocomplete because it could complete about a second's worth of work of a software engineer. Today, you can give an LLM a software engineering task and it'll complete about an hour's worth of an engineer's effort. If we're able to continue to maintain that level of innovation, and there's a lot of ifs that go with how far these things can go. In 6 years from now, you can give an LLM a month's work of a software engineer on one shot on that. So in that situation, how do you design for systems where a single shot LLM, mind you, it might take 4 hours to run, but a single shot LLM can do a month's worth of somebody's work on that. And so it really upends the entire principles of system design, because system design is about decomposing the work and then having these sort of units that can manage that. But as LLMs get more and more productive, you have to rethink about systems from letting go of this sort of decomposition and instead really trying to harness it to do that work. And then the hard part is, okay, you did a month's worth of work, how do I know it was any good or not? So that it's amazing where the world's going to go with this.
I was listening to Elon Musk and Jensen. They're talking about running out of power to run all these AI factories.
Yeah, that's what they say. But that's also an argument that is convenient. That's an argument that's necessary for both of them because they need AI to be a globally adopted technology stack. And so I'm a little irritated with Altman, Musk, and Jensen in that they're definitely telling a narrative that the world's demand for AI is a narrative that's convenient for all of them. I don't know if the adoption curve is as strong as they'd like it to be or they need it to be for them to have the sort of success. But don't get me wrong, AI is wonderful technology and there is getting adoption, but it needs to kind of continue to hockey stick. And I just don't see that happening. I don't think we've seen the killer use cases yet that is going to cause it to hockey stick adoption to that level of data center demand.
Yeah, it's definitely growing. I think to your point, I think it still has some ways to go. So thanks again, Tyler, for joining us and
Right.
your front-row view into like how agentic AI is evolving in enterprises. I think your examples are great, and I'm surprised to see the level of agentic AI being used right now, which is great.
That's awesome. Thank you for having me.
This was a fascinating deep dive. There's one thing that I'm taking away from this is that agents in production are less about clever prompts and more about dependable systems. Whether you're thinking about multi-agent workflow, agent-to-agent protocol, or just letting a single LLM call APIs, trust is everything. Thanks again to Tyler for sharing your insights from the trenches. And if you're experimenting with agents, hit subscribe and check out past episodes where we unpack how real teams are using AI across dev cycles. Stick around for the final bite. My closing thoughts coming up next. What really stuck with me from this conversation is that agents aren't just clever AI hacks, they're systems. And once you wire them up into production, it's no longer about prompt engineering. It's about system design, guardrails, failovers, entity, observability, and trust loops. I love the framing of agents as systems that strive towards perfection, but never reach it. That mindset shift is powerful. It also reminded me how far we still have to go. While agent frameworks are getting easier, running agents safely at scale with real-world consequences, that's still a craft. And the stack for that is still being built. If you're working on an agentic system or even just experimenting, I'd love to hear what you're running in production, what's breaking, and how you're designing for the trust. That's it for the final bite. See you again next time on DevAI.